Hello everyone, my name is Sine Kim and I am currently the head of secondary at an international school in Seoul, South Korea. Today I will be presenting my needs assessment titled Self-Efficacy in Mathematics English, Mathematics English as a Second Language. So this study was completed as part of my Educational 522 Research Methods course at the University of San Diego. To start, let me give a bit of context. So at my school, all of our students are ethnically Korean and come from highly educated, well-resourced families. We are located in one of the richest cities in the Seoul metropolis. And more than half of my students have completed their primary education in Korean public schools. They are very exceptional in mathematics and logical reasoning. And we have MAP tests and WIDA, tests to show this data. But we also noticed that many struggle to feel confident in English, even though English is the language of instruction in standardized testing. So this created a tension. Students who can easily solve complex math problems, they often hesitate to speak or write in English, even when they know the answer. So I wanted to explore whether their strength in math could serve as a foundation for building greater confidence in English. And more broadly, how we can reframe multilingual students from a deficit lens to an asset-based one. So my study is grounded in Albert Bandura's 1977 theory of self-efficacy. He defines self-efficacy as a belief in one's ability to succeed at a specific task, and it often predicts performance more strongly than skill alone. So he identified 4 key resources: mastery experiences, vicarious learning, social persuasion, and emotional states. I chose this framework because it perfectly captures what I see every day. Students who feel confident in math persist through challenges, while those who are uncertain in English often give up very quickly. So understanding this dynamic helps me view English learning just as much as a confidence issue as it is a language issue. My guiding question thus became, what is the relationship between English self-efficacy and math literacy among mathematically proficient middle school ELLs in rigorous academic setting? This question connects to issues of equity and inclusion, whether instead of seeing ESL learners as lacking, it asks whether their strength in one domain can empower them in another domain. This also aligns with the Seoul's mission of promoting social justice by valuing students' multilingual and multicultural identities. So 2 studies shaped my work. First, the Zhang, Kim, and Lee work that showed how higher efficacy in AI-assisted language learning actually reduced classroom anxiety and increased willingness to communicate, suggesting that confidence directly affects language engagement. Second, Chambers, Walpole, and Outlaw examined how mastery experiences sustain confidence over time and influence persistence towards college enrollment, often beyond resource barriers. So both of these studies emphasize that belief in one's ability can outweigh external factors. However, very few studies explore this across academic domains, such as how math confidence might influence English learning, which is where my project adds a new perspective. So to explore this question, my research question, I designed a quantitative Likert scale survey using a 1 to 5 rating scale from strongly disagree to strongly agree. This survey was given to middle school ELLs or students who are in our English program. But because I have limited access to my actual students, about 1/3 of the survey responses were simulated by my peers, whom I asked to represent middle school Korean students from urban high-income settings. So the survey included 5 domains, or several domains. First, we looked at there were questions targeted for general self-efficacy, then English self-efficacy, English literacy, math self-efficacy, math literacy, and cross-domain items linking both of these domains. Several questions were adapted from Lee, Park, and Bong to ensure reliability, and I collected feedback from my peers to strengthen the face validity. So I selected this quantitative design because it measures learners' perceived confidence across both English and math using parallel rating items. by quantifying self-beliefs rather than test scores, I believe that it captures how confidence in one academic area might influence confidence in another. This is a very core idea in self-efficacy theory. And using a consistent 1 to 5 scale also made it possible to compare and correlate results across domains, perfectly matching the exploratory intent of this study. So let's take a look at the overall results before diving into each finding. You'll find that the averages across all domains were above the midpoint of the 1 to 5 scale, indicating that generally positive confidence existed among students. At the same time, the relatively high standard deviation suggests that there's a wide variability among students. Some students really feel very confident overall, but the degree of the confidence, there was a lot of variance, yeah. So this pattern of strong correlations but diverse individual experiences provided the foundation for the next few slides, where I will highlight specific findings and what they reveal about how math and English confidence interact. So I would just like to highlight before I get into the details that since the sample size was small, I'm not trying to make any broad claims. These findings are preliminary, and I believe they provide a valuable snapshot of possible patterns worth exploring further. So this slide shows the correlation heat map between the 4 self-efficacy domains: general self-efficacy, English self-efficacy, English literacy, and math. As you can see, all the correlations are very high, above 0.95, 1 being the maximum, meaning that students' confidence in one area is very strongly connected to their confidence in others. For example, students who felt capable in math tended to report high English self-efficacy as well, and vice versa. In other words, self-efficacy appears to operate as an interconnected belief system rather than isolated skills. When students view themselves as capable in one subject, that sense of competence seems to spill over into other domains. So students show strong math confidence, but slightly lower confidence when English entered the picture. For example, the mean for I complete my math homework in a timely manner was 4.02, and I can apply math concepts to situations outside class was 3.9. But when asked questions like, I feel confident using English in math class, the average dropped to 3.77. In short, these students are mathematically capable, but their English proficiency moderates how fully they can show that ability. And second, I found that confidence in English also varied by skill. Students felt stronger in listening and comprehension, where the means were 3.88 and 3.82, than in speaking, 3.67. So receptive skills felt accessible, but producing precise academic language, especially while explaining math reasoning, was harder for these students. This points to a need for scaffolded oral practice and explicit support for academic vocabulary. And third, I noticed that most students agreed that math ability supports English learning, but the standard deviation was unusually large. Standard deviation was 2.29. Some said that math helps because it builds logical thinking, and others were unsure. This wide variability shows how personal and contextual factors can shape whether students experience this cross-domain connection. I also wanted to delve into some subgroup patterns that I noticed through my data. So students with longer ESL enrollment tended to report lower English self-efficacy. So the longer you were in the ESL program, you feel less confident with your English competency. Advanced math students showed higher math confidence, but greater variation in English confidence. So possibly because advanced math demands more language precision. There's a lot of word problems and a lot more, you need more English understanding as questions become more complex. And I also noticed that female students scored slightly higher in both math and English confidence overall. These patterns remind us that even in high-performing contexts, students' confidence journeys differ in meaningful ways. So the use of a standardized Likert scale survey provided a lot of measurable insights in students' perceived confidence and allowed direct comparison across math and English domains. So because this approach focuses on self-beliefs rather than achievement, it aligns with self-efficacy's theory's emphasis on motivation and perception. The results suggest that English proficiency clearly moderates how confidently ELLs apply math skills, this reinforcing the need to support oral academic language. So we need to be giving students more opportunities to explain their reasoning aloud. Math can also serve as a bridge for English learning, helping students practice structured, logic-based communication. At the same time, we saw that there's a large variation in confidence levels. So what we can conclude is that self-efficacy support must be differentiated. Future resource could pair this with quantitative, surveys, with more quantitative surveys, or with qualitative interviews or classroom observations. So I strongly suggest mixed methods, research in the future. And I hope that this will, help us better understand these patterns in students' lived experiences. And of course, there are limitations. The small simulated sample limits generalizability, and self-report data may not perfectly reflect actual performance. Still, as I mentioned earlier, these patterns highlight promising directions, particularly the potential of mixed methods research to deepen our understanding of how math-based confidence can support English development. Here are some major sources that guided this study, all of which helped connect confidence, persistence, and language learning. To conclude, my needs assessment suggests that math efficacy can be a meaningful bridge to English confidence, especially when educators intentionally link the two. Thank you so much for listening. I'd be happy to answer any questions or continue this conversation. Thank you.